Alright, welcome back. Looking at another method in solving integration by parts, and I'm sure you will love this. Alright, that is table of integration. Table of integration. So before we look at the steps, before we look at the question, let's first look at the steps. First, you break up the integral into two parts in the normal way. And hope you know the normal way, where we choose u and v. And you know how to choose that already. 2. Differentiate u respectively until it terminates to 0. This part is very necessary. Until it terminates to 0. It doesn't mean that if it doesn't terminate, if your u doesn't terminate to 0, you will not, you can't use the method. You can still use it in another way. I will show you. 3. Integrate v respectively as many times as we differentiate u. Alright? But the number of times that you integrate the v should correspond to, or the number of times you differentiate u should correspond to the number of times you integrate v. Take down product diagonally. Take down product diagonally. That means that we will multiply it diagonally. Alright? Diagonally. Proceeding each term, plus or minus. So you'll be adding plus, minus, plus, minus, plus. Now, 5. Sum up the product to get the results. As I'm talking, you may not be getting what I usually mean well, but you get it when you're solving this question. So you set your u, you set your v, but here I may be representing the v by dv, but don't worry, it's still the same thing. Alright. So you multiply this, that's what we mean by the product, the diagonal. The product diagonal. Multiply this by this, multiply this by this. So it's like you differentiate, you get second derivative, first derivative, second derivative, third derivative, and the integration, to integrate this, you get this, integrate the v, you get w, then you integrate this result, which is the w, then you get like that. Alright. So then you bring plus, minus, then you multiply. And the sum of product is our what? Our results. Let's stop the talking and try press one question. Okay. So first of all, you set u, which is always this, you know already. Then here, we are not going to write v is equal to integral of e raised to power s ds. Watch. We are not going to bring the integral sign. That is why we are bringing the v is equal to e raised to power s. Just this. Okay? I hope you're okay now. Now, that is the first step. Differentiate u respectively until it terminates to 0. That is why if you pick u to be the polynomial, it's going to help you, because anytime we differentiate, the power will reduce to 1. So it terminates to what? 0. That is what happened to the polynomial. But with this, if you differentiate 8,000, it's still e raised to power s. Even if you integrate 8,000, it's still e raised to power s. So 3. Integrate v respectively as many times as we differentiate u. I hope you can see that. So differentiate this, you get 3x squared. Differentiate this results again, you get what? 6x. Differentiate this, you get 6. Differentiate this, you get 0. Now you move to the integration. Oh, this O is still e raised to power x, but let it match. It's still e raised to power x. This is still e raised to power x. It's still e raised to power x. Alright, beautiful. I hope you love mathematics. I also love mathematics. Now, as we said, we are going to match each diagonally. Alright, so it's like this. It's not from here to here, it starts from here, the U, by ignoring this the V. Okay, so this to this to that. That is another way we solve it. And I hope you can remember that we have solved this same question before, and the results we had. Now, when we are done, you can go and compare. Take down product diagonally, proceeding each term plus or minus. So after that, you bring plus, minus, like that. Alright? Do you know something? If another one comes here, e raised to power x, if you differentiate this, you get 0. When this go to this, you get 0. That is why there is no need for that. Okay? I hope you can see what we have done here. Yeah, we are matching. So the final results for this integral by parts is going to be this times this. Don't forget the plus will come. So this times this, you get x to the power 3 e raised to power x. This to this, you get negative 3x squared e raised to the power x. Hope you can see that. This to this, you will get plus 6x e raised to power x. Woo! Nice method. This to this, you will get negative 6 e raised to power x. This to this, 0. So it's going to be like negative minus integral of 0 ds, and this is 0. So, let me say, that will be plus c. Simple. So when you are done, then you bring plus c. Very good. You are done, oh, we are done. It doesn't demand a lot of work. And here, the only thing you can do again is to factorize the common one, which is e raised to power x. So the final answer is this minus this plus this minus this plus c. And that is the same thing we had when we were solving it the normal way. Alright. Hope it's clear. Don't forget, the first one here will be ignored so that you can get the slope well. It's not like this. Don't forget. Alright. We are going to try it on all that we have done. And you see it's the same thing. I'm going to clean it. Let me clean the steps. Now you know the steps of head by now. You know the steps of head. You should be able to know it's okay. Yes, you should. Good. Let me go to integral of e raised to power 3 with s ds. Which will be your u? Your u is ln s. Is that not so? Alright. Then your dv integral of, as I said, when you bring dv, you don't bring the integral sign. S to the power 3. So now, differentiate this. You get 1 over s, which is the same as this. And when you integrate, you get this. How do you get that? And when you integrate, you get 2. You see, it keeps increasing, it keeps decreasing. And I want you to realize something in this question, that there will be no way this can be giving you 0. There is no way. Let's watch. Here you get negative 6 x to the power negative 4. Here you get 6 4. Good. So you can see that 6 4, let me see, 24. Because you know 6, 24. So here we get 24 e to the power negative 5. In fact, there is no way this can give you 0. Now let's look at something here. Here you get x to the power 4 over 4, x to the power 5 over 5, x to the power 6 over 6. There is no way nothing of this can get you 0. And there is no way also that this can be repeated. The question can be repeated back. There is no way. When you're doing it, table of integration, or with this method, there is no way that this is going to help you. It's unless you go by the other method, that is the way that you can use to get solution to what? This question. Don't forget that. Alright. So I won't encourage you to use this method whenever you are having this economical and a natural logarithm. I hope you are okay with me now. Alright. Very good. Let's look at integral of x squared sine x ds. What will be our u? X squared dv sine x. We can even increase the power to 3. Differentiate this, or to 4, any of it. Or we can make it like this. Differentiate this, you get 6x squared. 12x 12 0. Hope you can see how it was terminating. Alright. But looking at something, it's like a number line. Here is 0, here is positive 0, here is positive values, here is negative values. So differentiation always reduce the powers, okay? So once your power is positive, it will reduce till you get to what? 0. Now here we know that negative 1. We know that negative 1 is less than 0. That means that 0 is greater than what? Negative 1. So if your power is negative, it will keep reducing to this side, and there is no way that you're going to get 0. I hope you can get, there is no way that you're going to get a constant. And if you don't get a constant, if you get a power of 0, that is when you're going to get a constant. Even a ratio to 0 is 1. Whereby when you differentiate, you get what? 0. So that is why if your power is negative, it will help you. Now differentiate this. You get, integrate this, you get negative cos S. It should line up. Here you get negative sign S. When you integrate this, you get this. When you integrate this, you get this. When you integrate this again, you get negative cos S. No, it will be positive. Then integrate this, you get negative sign S. Now you match. We are marching to Zion. Beautiful, beautiful Zion. So this match. Alright, this corresponds to the last one. So now, plus, minus, plus, minus, plus. So you see the final result is going to be this plus this. You get negative 2s cubed cos s. Negative 6s squared sin s plus 12s cos s minus 12 sin s plus c plus c. Therefore, when you integrate this, the result is going to give you this. Very nice. Taking my time to show to you the concepts under this section. So make sure you understand it well. So that is going to be that. And in case something can be factored out, you can do that, but I'm not sure. Very good. So that is what you are going to get for such. So see the number of times here. If the power is 3, how many times you go by integration by part? 1, 2, 3. Yeah. 1, 2, 3. Before it terminates to 0. If the power is 3. So if the power is 3 here, see the number of times. 1, 2, 3. Before it terminates to 0. So if the power is 2, you go 2 times. If the power is 4, you go 4 times. If the power is 5, you go 5 times. It's like such. Very good. Looking at our last one. You don't want me to close. That's the last answer. Sorry, that's the last question that we are going to solve. Let's look at our last question. That's how study is. If you enjoy how the thing is, don't want the video to end. That is why you have to subscribe to Math Expert video tutorials. And not only you have to enjoy, you have to also share our links to your friends in any university that the person find him or herself doing mathematics. Share to them so that they can watch it and also benefit from what you are also getting here. Alright? Very good. Because if you don't get our YouTube channel to them, in the time they confront with any challenging question, they will be sending to you for your view. It may be that you are busy at that time, but if the person watch our video and he grab the concept, right, any question that the person will get, he or she will be able to do it. Alright, let's look at E raised to power S when this meet with 8 meter. Do you know 8 meter? Sine. Let's take now 2s ds. The same way, you know, we represent this by u raised to power s, v, dv, which is sine 2s. Sorry for those who don't understand the language I'm speaking. Alright, so yeah, what we are going to do is interesting. That's why I'm singing that. Don't forget, the question is going in line with what? You don't worry. Let me get rid of the 2 for now. The question is going in line from the button. The integral function is going in line with what? E raised to power s and sin x. Please, you know that there is no way that this can terminate to 0. There is no way that this one also can terminate to 0, because it's like sine, cos, sine, cos, sine, cos. Alright? And it's negations. And this one, e raised to power x, e raised to power x, it will repeat till you die. So watch well. And when you are watching, watch it diagonally and see whether when this can repeat in it. So let's move. This is e raised to power s, e raised to power s, e raised to power s, e raised to power s. Very good. What will this give you? Negative cos s, negative sine s, and this will also give you, cos s, because the negative to cancel out. Now what is this real? Whether you get e raised to power s and sine? Not. Yeah. No. Yeah. Hope you guys see something. No. What will be the next one? You know the next one. What will be the next one? That will be sine s. Alright? So see something. They're going to get rid of some parts. Plus, minus. I have realized something, that's why I have ended this part. Now, let's move on. It's going to be equal to what? This time is you get negative e raised to power x. Don't forget that the I is integral of e raised to power s sine x ds is equal to, multiply this by this, you get negative e raised to power s cos x. Now, here is negative, that also, so positive, so plus e raised to power s sine x. Woo! Now, just after this, just here, we have the question inside, e raised to power s sine s. If you try to go again, you will be e raised to power s cos s. And you will see that the thing is repeating here again, e raised to power s sine s. And the next one I'm trying to be e raised to power s cos s. And the next one, e raised to power s sine s. If you don't stop it, you will die. So just get rid of this part. And just here, you need to only know that the last part, since that place is not ending with 0, it's not terminating to 0, the last part will be integral of e raised to power s sine s ds. Don't forget that when it terminates to 0, that last part, even though we don't write it, but that last part is 0, let's say 0 e raised to power x. Because if you differentiate x, you get 0. So let's say 0, sorry, if you differentiate a constant, you get 0. So let's say 0 e raised to power x. And this whole thing is what? 0 dx. And when you integrate 0, you get c. You get c. That is why we end by adding plus c. So we do, when it terminates to 0, we don't repeat the integral sign because we know that integral of 0 is c. But if it don't terminate to 0, you need to bring the integral sign. And now you know that this side is the same as this. That is why we did that. That is why we did that. Always don't forget what is here will repeat. So with this, what are we getting like that? I'm sure there is a mistake somewhere. Here is negative. Or, yeah, that place is negative. That place is negative. Very good. So when we send this to this side, we get 2 integral of e raised to power s sine s ds. Okay? And with this, we get negative e raised to power s cos s. So you divide one side by 2, so you get this. So this becomes the final answer. But what I'm projecting to you is that the function inside of the integral function of the by part repeats. Let's try our next question. Integral of e raised to power negative s sine 3s ds. So you set your u. I would like to do that here. I want it to be on top small. So you set your u to be equal to e raised to power negative s, dv to be equal to sine 3s. So this will give you negative e raised to power s, negative e raised to power s. No, this one here will go negative e raised to power s, e raised to power negative s, negative e raised to power s. Now take your time. Let's go to this. But don't forget what should be. It's taking note of e raised to power negative s and sine 3x. So here we get, differentiate this. We will get negative cos 3x by the constant. We get 1 over 3. Then when we differentiate cos, let me leave space with this because of the over there. Alright, so here we get this. Now here to this we get negative sine 3x. Now 1 over this again. So here is over 3 already. So 3, 9. I hope you can see that. There we go again. But don't forget that the thing will repeat. So always don't forget to check. So here we get 1 over the 3 over 1 multiplied this. So we get 3, 9, 3, 27. 27. So here we get negative cos. So this will go. So cos 3s. Now don't forget, check. E raised to power is e meeting with sine. Is e, oh yes, it's meeting with this here. So like this. Then we forget of this part because it's just here, so plus and minus. Alright. So this is going to be equal to, this is going to be equal to e raised to power negative s, so negative 1 over 3 cos 3s. Hope you can see that. Negative 4 plus, but there is negative here also, so that place will be minus, because we are multiplying this by this. Alright, and we know that here is negative, so negative of this will be positive, but since here is negative, it will be there. So negative e raised to power s 1 over, so 1 over 9 sine 3s. And as I said, since it don't terminate to 0, we bring our integral sign. So here we get, let's make it better. Here the constant is this. To this, alright? So let's send that to this side. So we get e raised to power ds plus 1 over 9 integral of e raised to power negative s sine 3s is equal to this. So we can add, so it gets 1 plus 1 over 9. And 1 plus 1 over 9 is going to be, okay, so this is 10, this is 9 over 9. So we get 10 over 9. So it's going to be 10 over 9. So 10 over 9 integral of e raised to power negative s sine 3s. Alright, so when you multiply it by 10 over 9, that is what you're going to get to be your final answer. So finally we get negative 9 over 30 e raised to power negative s cos 3s plus c. Alright, please I entreat you to solve more questions, and that is a word form for only mathematics experts. Alright. I would like to end here for you to try your best on these questions and any other that you find yourself across. Very good. Any of the method that you like, you can choose to solve. You can choose to use it to solve it. Okay? So we have e raised to the power 2s sine s ds. We have integral of s to the power 4 e raised to the power s ds. 3, we have integral of s squared sine 2 s. Alright. That is that. Keep on practicing more. Very good. See you in your next video. And I'm sure you are waiting to hear from me that where are we getting to? Where are we getting to? Yes, we are getting to an interesting part, and that is techniques of trigonometric integration. Techniques of trigonometric integration. Please, that is different from trig substitution. Don't forget, it's not the same. I'm going to give you the technique. In fact, I was applying some of the techniques when we were doing trig substitution. When we were doing trig substitution, I was applying such a technique, and we'll see how easy and reliable that can be. See you in that video. Until then, bye bye.